Alright, today I just want to show you guys something kind of interesting, and that's how we can kind of trace the limit definition of the derivative from the alternative form of the derivative. This is just a cool thing that I did not really know until I just started playing around with stuff. Maybe you already knew this, but I didn't. I just kind of had fun with it, so I just want to show you guys what I found. So recall the alternative form of the derivative is the limit as x approaches c of f of x minus f of c over x minus c. And what this gives you here is the derivative at x equals c. So f prime of c if we use Lagrange's notation. But if we want to actually get this into the form of the limit definition where we can find f prime of x, well, firstly, we can't just plug in x in for c, right? Because if we let c equal x here, we'll just get 0 over 0, and then we get really nothing out of that. So how else can we do this? And so if we kind of look at this here, let's say that I set c equal to delta x. So if I let c equal to, or to x plus delta x, sorry, if I let c equal to x plus delta x, then I'll have the limit as x approaches x plus delta x of f of x minus f of x plus delta x, and then that all over x minus x plus delta x. And then so if we do a little bit of simplification here and just some rearrangement here, I mean, of course, hopefully you'll see here, and I can write down all the steps if we really need to see them. So we'll then get, I'm going to write this as negative f of x plus delta x plus f of x, and then that all over, and then this is x minus delta x. And so these x's right here cancel, and so we get the limit as delta x, as x approaches x plus delta x, and then we have negative f of x, or negative f of x plus delta x, and that plus f of x all over negative delta x. And so now I'm going to factor in a negative here, and I'm going to rewrite this as the limit as x approaches x plus delta x. And then we have negative of f of x plus delta x, and then that minus f of x all over the negative, and I'm just going to put a set of parentheses here in front of the to surround the delta x, because then you can see here easily that the negatives will cancel, and again you can distribute this negative sign or this negative 1 here to show that this is negative f of x plus delta x, and then that plus f of x, and then that over negative delta x, which is the same thing here. And so if we then see here that the negative signs cancel, we then get the limit as x approaches x plus delta x of f of x plus delta x minus f of x all over delta x. And then what you notice right here is, well, this is the same, right? This part right here is the same as the limit definition, but then wait, this is as x approaches x plus delta x. Well, that's not the same as delta x approaches 0. So how do we solve this? Well, really, think about what this itself is saying. It's saying as x approaches delta x. Now recall, when we went over the limit definition of the derivative, whether that's through our derivatives marathon or through the understanding, not memorizing series, if we look at the x-axis, right, if we have some x here, and then we have some x plus delta x here, where the distance between x and x plus delta x is indeed delta x, and you can verify that by doing x plus delta x minus x, which should then give you delta x, which is the distance. And so if we look at when as x approaches delta x, that means that this delta x is getting closer, or this x is getting closer to this delta x. Now, if this x is getting closer to this delta x, right? That means that they are getting closer together. And what's happening as they're getting closer together? This delta x, this distance is getting smaller. So this delta x is then, as a result of x getting closer to delta x, approaching 0, because that distance is getting smaller and smaller. So then, therefore, we can conclude that as x approaches x plus delta x, that distance between them, right, because x is getting closer, they're getting closer to each other, that distance must be approaching 0, meaning it's getting smaller and smaller. And this, of course, kind of mirrors or mimics the limit definition of the derivative. So therefore, we can conclude from this that, indeed, the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x is our limit definition of the derivative for f prime of x. So this is really something cool, right? We're getting from here to derivative at a point to just the general, again, the slope function, the derivative itself, the general form for NEC, just finding that expression itself for the derivative. So that's really, or the slope function as I call it. And so this is really cool. It's showing that this is just not a made up kind of formula here. We can trace it back to the limit definition of the derivative. But of course in a future video I will go over the formal proof just in general of how we get this. And hopefully you see that this kind of mimics or mirrors the y2 minus y1 over x2 minus x1, or like the average rate of change formula. So we'll do that in another video, but this is just kind of cool, just playing around with stuff and seeing like how we can get from here to here. This is just something, again, I did not base this off of a teacher that I talked to or like a video that I saw. This was just me, like I was just writing down random stuff on a piece of paper or my iPad or something. I was writing down this and I was trying to see like, is there any way I can get from here to here? And I was like, okay, if I set c equal to x, then we'll get f of x minus f of x, which is 0. Then over x minus x, so then it's 0 over 0, then I don't know. C equals to, then I thought maybe c equals to x plus delta x, and we're kind of mirroring this limit definition, and then I factor out negative and stuff like that, and then I'm like, hey, now I have x approaches x plus delta x, and I'm like, wait a minute. Like, let me sketch that out. Like, that doesn't even make sense. Why is x approaching x plus delta x? What does that even mean? And then I was like, hey, let me sketch it out. I'm saying, hey, as x approaches x plus delta x, that means it's getting closer. And since delta x is the distance between them, that distance is getting smaller and smaller, and it's approaching 0. Instead of, hey, we have the limit definition from that. So it's really cool. Just want to share with you guys something that I found a little bit kind of interesting. So, yeah, hopefully you enjoyed the video. Gotta stop the video.